Hello, in this lecture we will find the diameter of the semicircle. In the drawing we have a semicircle. AB is the diameter of this semicircle. AD equals to 7 units. DC equals to 15 units. And CB equals to 15 units also. And we want to find out the diameter of this semicircle or the size of AB. Okay, so first of all we will make a construction. We will connect together points B and D by a straight line. So actually the peripheral angle ADB equals to 90 degrees. It is a right angle according to rule number 1 that states that peripheral angle that rests or resting on the diameter of the semicircle or circle equals to 90 degrees. Okay, so I write down rule number 1. Rule number 1 states that peripheral angle resting on the diameter of a circle equals to 90 degrees. So I will read rule 1 again. Rule 1 states that peripheral angle resting on the diameter of a circle equals to 90 degrees. Actually, this angle ADB, the peripheral angle ADB rests on the diameter of this semicircle. That is to say, peripheral angle ADB rests on AB, that is the diameter of the circle. AB is the diameter of the semicircle. Therefore, angle ADB equals to 90 degrees according to rule 1. Angle ADB that rests on AB, that is the diameter of the semicircle, equals to 90 degrees. Okay, so this angle is a right angle. Okay, in the next step we will define the center of this semicircle at point O. Again, point O is the center of this semicircle. In the next step we will join together points O and C by a straight line. and we will also join together points O and D by a straight line. Actually, chord AD is the radius of this semicircle. I will mark it as R, abbreviation for radius. Actually, OC is also the radius of this semicircle, and OB is the radius of this semicircle because it starts from the center of this semicircle, that is to say from point O, and ends at point B, that is a point on the circle itself. Therefore OB is the radius of this semicircle. The same thing about OD, it starts from the center of the circle and ends at point D, that is a point on the circle itself. Therefore chord OD is the radius of this semicircle. So in the next step we will focus on triangles AOD, on triangle COD and triangle OCB. So we focus on the green triangle OCD, and we will also focus on triangle OCD, that is the orange triangle. Okay, so in triangles OCD, the green triangle, and triangle OCB, that is the orange triangle, side DC of the green triangle equals to side CB of the orange triangle. Those both sides are equal to 15 units according to what is given us in the question. So DC of the green triangle equals to CB of the orange triangle. Both those two sides equal to 15 units. Okay, DC equals to CB. Both those sides are equal to 15 units in their size. Okay. And also side OD of the green triangle is equal to side OB of the orange triangle. Both those two sides equal to the radius of this semicircle. Okay, so side OB of the green triangle equals to side OB of the orange triangle. Both of those two sides are equal to the radius of this semicircle, and OC is a common side. That is to say, it belongs to the green triangle, and side OC also belongs to the orange triangle. So OC equals to OC. Okay, OC equals to OC. So we actually proved that all the sides of the green triangle are equal to the sides of all the sides of the orange triangle. Therefore, the green triangle ODC is congruent to the orange triangle OCD. Okay, the green triangle OCD is congruent to the orange triangle OCB according to side rule. According to side rule. Side rule means that if you prove that all the sides of one triangle are equal to all the sides of another triangle, then those two triangles will be congruent to each other. Okay? So from the fact that the green triangle is congruent to the orange triangle, we can deduce that angle OCD, this angle, is equal to angle OCB. Again, angle OCD of the green triangle, this angle, is equal to angle OCB of the orange triangle, according to the rule that corresponding angles in congruent triangles are equal to each other. That is to say, the green triangle is congruent to the orange triangle, therefore the corresponding angles in these congruent triangles are equal to each other. Therefore, angle OCD is equal to angle OCB. And if we define angle OCD as alpha, then angle OCB will be also equal to alpha, because those two angles are equal to each other. Okay? Angle OCD equals to angle OCB, both those two angles are equal to alpha. Okay? In the next step, we focus on triangle DCB. This triangle DCB. So, in triangle DCB, we know that side DC of triangle DCB equals to side CB. DC equals to CB. Both of those two sides are equal to 15 units. It is given us in the question. So DC in triangle DCB, side DC of the triangle is equal to side CB. Both those two sides are equal to 15 units. Therefore, angle BDC is equal to angle DBC. Those two angles are equal to each other according to rule 2. According to rule 2, rule number 2 states that in front of equal sides in the triangle, in front of equal sides in the triangle, there are equal angles. I will read rule number 2 again. Rule number 2 states that in front of equal sides in the triangle, there are equal angles. So, rule number 2 states that in front of this side that equals to 15 units, we have angle DBC, and in front of this side that also equals to 15 units, we have angle BDC, and according to rule number 2, those two angles that are located in front of equal sides are also equal to each other. That is to say, angle CDB, this angle is equal to angle DBC. Okay? Again, angle CDB is equal to angle DBC. According to rule number 2, those two angles are equal to each other because those two angles are located in front of equal sides. This angle is located in front of DC that equals to 15 units, and this angle is located in front of CB that also equals to 15 units. Therefore, those angles that are located in front of equal sides are also equal to each other. That is to say, angle CDB is equal to angle DBC. Okay, and if we define angle CDB as theta, then angle DBC also will be equal to theta because of the fact that those two angles are equal to each other. Okay, so here angle DBC equals to angle CDB. Both of those two angles are defined as theta. Okay, so angle CDB equals to angle BDC equals to theta. Okay, so in the next step we'll focus in the next step we will define this point as point E, this point is defined as point E, and we'll focus on triangle ECD, and triangle ECB. Okay, we will focus on those two triangles. On those two triangles, we know that side DC of the green triangle is equal to side CB of the orange triangle. Both those two sides are equal to 15 units in size. Okay, side BC of the green triangle equals to side CB of the orange triangle. Both those two sides are equal to 15 units. And side EC is a common side. It belongs to the green triangle, triangle ECD, and also side EC belongs to the orange triangle, triangle ECB. So EC equals to EC. It is a common side. Okay, EC equals to EC. It is a common side. And also we know that those two angles are equal to each other. Okay, angle DCE is equal to angle ECB. Both those two angles are equal to alpha. Okay, angle DCE is equal to angle ECB equals to alpha. So we actually proved that two sides and the included angle of the orange triangle are equal to two sides and the included angle of the orange triangle. So two sides and the included angle of the green triangle are equal to two sides and the included angle of the orange triangle. The included angle is the angle between the two sides. That is to say, the included angle of side DC and side EC in the green triangle is alpha, and the included angle of side EC and side BC of the orange triangle is also alpha. So we actually proved that the green triangle, triangle DEC, is congruent to the orange triangle, triangle ECB. Okay, we proved that the green triangle, triangle DEC, is congruent to the orange triangle, triangle ECB, according to side angle side rule. According to side angle side rule. Okay, so the green triangle DCE and the green triangle DEC is congruent to the orange triangle, triangle ECB, according to side angle side rule. And again, side angle side rule states that if you prove that two sides and the included angle of one triangle are equal to two sides in the included angle of the other triangle, then you actually proved that those two triangles are congruent to each other. Okay, therefore those two triangles are congruent to each other according to side angle side rule. Okay, so from the fact that those two triangles congruent to each other, we can deduce that angle DEC of the green triangle is equal to angle CEB of the orange triangle. Those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles are congruent to each other, therefore their corresponding angles also will be equal to each other. So angle DEC of the green triangle equals to angle BEC of the orange triangle according to the rule that corresponding angles in congruent triangles are equal to each other. So if we define angle DEC as x, then angle BEC also will be equal to x, because those angles are equal to each other. Okay, so angle DEC of the green triangle is equal to angle EBC of the orange triangle, and both those two angles are equal to x according to our definition. Okay, and what is the value of angle DEC? Angle DEC, this angle DEB. What is the value of angle DEB? Angle DEB equals to x plus x from one side. Okay, so angle DEB equals to 2x plus x from one side, so it equals to 2x from one side, but from the other side the size of angle DEB is actually 180 degrees because of the fact that DB is a straight line. In the beginning of the lecture, the first thing that we did is we draw a straight line between points D and B. So DB is a straight line. And the sum of the angles at a certain point along a straight line at one side of a certain point, the sum of the angles at a certain point and at one side of a straight line is equal to 180 degrees. So if we focus on point E and on the straight line DB, and if we sum the angles on the upper side of the straight line DB, then the sum of the angles on the upper side of the straight line DB at point E will be equal to 180 degrees. So the size of angle DEB equals to 180 degrees because of the fact that DB is a straight line and the sum of the angles along a straight line at a certain point, and the upper side is equal to 180 degrees. So we have this equality that states that angle DEB equals to 180 degrees from one side, but from the other side, the size of angle DEB is 2x. So from this equality, we can deduce that 2x equals to 180 degrees, or 180 degrees equals to 2x. Okay? 180 degrees equals to 2x. So here we can divide this equality by 2, and we will get that x equals to 90 degrees. Okay, so we found out that angle x is a right angle. So those two angles are right angles. So we can delete x and substitute it by 90 degrees. Okay, we have two right angles because x equals to 90 degrees. Okay, so angle DEC is a right angle, it equals to 90 degrees, and also angle CEB is a right angle, it equals to 90 degrees. Okay, we found out that those two angles are right angles. So in the next step, we will focus on OC. OC is the radius of this semicircle. So it equals to R. Why? Because OC is is a chord that starts from the center of the circle, that is to say from point O, and ends at point C, that is the point on the circle itself. Therefore, OC is the radius of the semicircle, that is to say OC equals to R. Therefore, OC that equals to R is also a straight line. OC is a straight line. Okay, OC is a straight line. So again, we know that the sum of the angles at a certain point in the left side of the straight line OC will be equal to 180 degrees. So if we focus on point E, and on the left side of a chord OC, or of the straight line OC, then the sum of its angles will be equal to 180 degrees. So this angle CEB, that equals to 90 degrees, plus the value of angle OEB plus angle OEB will be equal to 180 degrees. Okay, so again, this equality states that the sum of the angles along a straight line at a certain point, if you focus only on the left side of that straight line, equals to 180 degrees. So angle 90 degrees plus angle OEB will be equal to 180 degrees. Here we can subtract 90 degrees from this equality, and we will get that the value of angle OEB is actually equals to 180 degrees minus 90 degrees is 90 degrees. So the size of angle OEB is 90 degrees. So this is a right angle. Angle OEB equals to 90 degrees. Okay? Okay, so we found out that the size of this angle, angle OEB, is 90 degrees. It is a right angle. we actually have a rule number 3. Rule number 3 states that the sum of the angles around any point is equal to 180 is equal to 360 degrees. So I will read rule number 3 states that, and read rule number 3 again. Rule number 3 states that the sum of the angles around a certain point is equal to 360 degrees, and especially the sum of the angles around point E is equal to 360 degrees. Okay, so we know that the sum of the angles around point E is equals to 360 degrees. So actually, if we define angle OED as Y, then we know that the sum of the 3 right angles plus angle Y must be equal to 360 degrees. So the size of angle Y plus the 3 right angles that are actually equals to 3 times 90 degrees in total must be equal to 360 degrees. Okay, according to rule number 3, the sum of the angles around point E, the sum of the angles around point E must be equal to 360 degrees. Okay, again, the sum of the angles around point E must be equal to 360 degrees. So if we define the fourth angle, angle OED as Y, then the sum of the 3 angles that we have already found out plus the sum of the fourth angle around point E must be equal to 360 degrees. So Y plus 3 times 90 degrees must be equal to 360 degrees. So Y plus 3 times 90 degrees is 270 degrees. Okay, so Y plus 270 degrees must be equal to 360 degrees. So here we can subtract 270 degrees from this equality in order to get the value of Y. So Y actually equals to, angle Y equals to 360 degrees minus 270 degrees, that is 90 degrees. So the size of the fourth angle, angle Y, is 90 degrees. Okay, so we can write here, we can draw here a right angle because angle Y is also a right angle. So we actually found out that all the 4 angles around point E are right angles, and the total sum of them is 360 degrees because 90 times 4 is 360 degrees. Okay, so in the next step we will focus on two triangles. We will focus on the big triangle, triangle ADB, and on the small triangle, triangle OEB. Okay? So I will draw again those two triangles, triangle ADB and triangle OEB. Angle ADB is a right angle. And we also know that angle OEB is also a right angle. So I draw again triangles ADB and the small triangle, triangle EBE, and triangle OEB. Okay, I draw again triangles ADB and the small triangle, triangle OEB. So on those two triangles, the big triangle, triangle DAB, and triangle EOB, we know that those two angles are right angles, therefore they are equal to each other. So actually angle ADB is equal to angle OEB. Both of those two angles are right angles, they are equal to 90 degrees. So angle angle ADB is equal to angle OEB. Both of those two angles are equal to 90 degrees. And we also have a common angle. Angle B is a common angle. It belongs to both the small triangle, triangle OEB, and angle B is also belongs to the big triangle, triangle ADB. So angle B equals to angle B is a common angle. And the third angle, angle DAB, will also be equal to angle EOB, to this angle. Again, angle DAB is equal to angle EOB according to the third angle theorem or third angle rule. third angle rule. So actually, third angle rule or third angle theorem states that if you have two triangles that are equal between them by two angles, or if two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles of those two triangles must also be equal to each other according to third angle theorem or according to third angle rule. Okay, so therefore we actually proved that all the angles in the big triangle ADB are equal to all the angles of the small triangle EOB. That is to say, those two triangles are similar to each other. Okay, so the big triangle ADB is similar to the small triangle triangle EOB according to angle similarity. Okay, so the big triangle ADB is similar to the small triangle EOB according to angle similarity. So because of the fact that those two triangles are similar to each other, the following relationship exists between the sides of those two similar triangles. The relationship is that OB over AB, OB of the small triangle over AB of the big triangle is equal to OE over AD. Again, because of the fact that the big triangle ADB is similar to the small triangle EOB, the relationship that exists between the sides of those two similar triangles is that OB over AB equals to OE over AD. Okay? But what is the value of OB? The value of OB is R, is the radius of the semicircle. And we also know that AO is also the radius of this semicircle because it starts from the center of the semicircle and ends at point E, that is a point on the semicircle itself. Therefore, AO is also the radius of this semicircle. So we have the relationship of OB over AB equals to OE over AD. And OB is the radius of this semicircle. And what is the value of AB? AB is the diameter of the semicircle, and it equals to R plus R. So AB equals to 2R. The diameter of any semicircle is also equals to 2 times the radius of the diameter of any circle or semicircle is always equals to 2 times the radius of this circle or semicircle. Okay, so we can know that AB equals to 2R even without looking in the drawing, because we know that AB is the diameter of the semicircle, therefore it must be equal to 2 times the radius of that semicircle. So we got that R over 2R equals to OE over AD. What is the value of AD? AD equals to 7 units. It is given us in the question. So in total we got the following equality, that R over 2R equals to OE over 7. R over 2R equals to OE over 7. So here R over R is 1, so R is cancelled. So in total we got that 1 over 2 equals to OE over 7, so I will write it down. 1 over 2 equals to OE over 7. Okay, we got the equality that states that 1 over 2 equals to OE over 7. Here we can multiply this equality by 7 in order to get the value of OE. Okay, so here 7 over 2 equals to OE. So OE equals to 7 over 2 units. We found out that OE, the value of OE, this line segment, is actually equals to 7 over 2 units. Okay, but what is the value of EC? EC equals to OC minus OE. Again, EC equals to OC minus OE. Okay, EC equals to OC minus OE. So EC equals to OC. What is the value of OC? OC is the radius of this circle, because it starts, is the radius of this semicircle, because it starts from the center of this semicircle and ends at point C, that is a point on the semicircle itself. Therefore OC is the radius of this semicircle, so OC equals to R minus OE. What is the value of OE? We have already found out that OE equals to 7 over 2. So in total we found out that EC equals to R minus 7 over 2 units. So EC equals to R minus 7 over 2 units. OE equals to 7 over 2 units. So in the next step we will focus on two right triangles. Triangle EOB is a right triangle because angle OEB is a right angle. Therefore triangle OEB is a right triangle. And also triangle BEC is also a right triangle. triangle BEC is a right triangle because of the fact that angle BEC is a right angle. This angle is a right angle, therefore triangle BEC is also a right triangle. So triangles OEB and triangle BEC are right triangles, and side EB belongs to both those right triangles. It belongs to the right triangle OEB, and also side OB belongs to the right triangle BEC. Okay, so therefore we will create the equality that states that EB square equals to EB square Okay, we created the equality that states that EB square equals to EB square, and we will implement the Pythagorean theorem on those two right triangles. And we have EB square times, in the first times EB square will be related to the right triangle OEB, and in the right triangle OEB, this triangle, EB square equals to OB square minus OE square. OB square minus OE square. So, and the second EB square, this EB square will be related to the right triangle BEC, and in the right triangle BEC, EB square will be equal to BC square minus EC square. BC square minus EC square. Okay, so EB square equals to EB square. In this side of the equality, EB relates to the right triangle OEB, and in the other side of the equality, EB square relates to the right triangle BEC. Okay, so in total we got this equality. But what is the value of OB? OB equals to R, because it starts from the center of the circle and ends at point B. That is a point on the circle itself. So OB square is R square minus OE square. What is the value of OE? OE equals to 7 over 2. We found out that OE equals to 7 over 2. So OE square will be equal to 7 over 2 squared, that is 49 over 4. Equals to BC square. What is the value of BC? BC equals to 15 units. It is given us in the question. So BC square will be equal to 15 square, and 15 square is 225. Minus EC square. What is the value of EC? EC, we found out that EC equals to R minus 7 over 2. So EC square will be equal to R minus 7 over 2 square. So in total we got this equality that states that R squared minus 49 over 4 equals to 225 minus R minus 7 over 2 square. So R square minus 49 over 4 equals to 225 minus here r minus 7 over 2 square equals to r square minus 7 over 2 square, that is actually 49 over 4, minus 2 times r times 7 over 2. Okay, so in total we got that r square minus 49 over 4 equals to 225 minus r square minus 49 over 4. Here we have 2 in the numerator and 2 in the denominator, so 2 over 2 is 1, so 2 is cancelled. What is left here is 7r, so I will open the brackets here. And we will get that r square minus 49 over 4 equals to 225 minus r square minus 49 over 4 minus plus 7r. So here we have minus 49 over 4 in this side of the equality, and we have minus 49 over 4 on the other side of the equality, so we can cancel minus 49 over 4. And what is left after we cancel minus 49 over 4? Here we will add r square to this equality, and we will get that r square plus r square is 2r square equals to 225 plus 7r. So here we will subtract 7r and 225 from this equality. We will get that 2r square minus 7r minus 225 equals to 0. So we got this quadratic equation, 2r square minus 7r minus 225 equals to 0. And here the coefficients of this quadratic equation is that a equals to 2, b equals to minus 7, and c equals to minus 225. Okay, so in general we have actually the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. So here actually a, b and c are the coefficients of this quadratic equation, and x is the variable that we want to find out. Okay, and about in our specific quadratic equation, we have already found out the values of a, b, and c, and the variable in our quadratic equation 2r squared minus 7r minus 225 equals to 0. The variable is r, so x equals to r. Okay, so x equals to r, and we have a special formula in order to find out the value of the variable of the quadratic equation. The following formula exists for solving out this quadratic equation, or finding the roots of this quadratic equation. The roots of this quadratic equation equals to x equals to minus b plus minus root of b squared minus 4 times a times c over 2 times a. Okay, so we will find out the roots of the quadratic equation according to this special formula. We know that x equals to r, and we have already found out the values of a, b, and c, so we will substitute x by r, because in our quadratic equation the variable is r, that is the radius of the semicircle. R equals to minus b. We know that b equals to minus 7, so minus b is minus 7, that is actually plus 7, plus minus root of b squared. B equals to minus 7, so b squared is minus 7 squared, that is 49. Minus 4 times a is 2, so minus 4 times 2 is 8, times c. C equals to minus 225 over 2 times a equals to 2, so 2 times 2 is 4. So in total we got that r equals to 7 plus minus root of 49 times minus 8 times minus 225. Minus 8 times 200 times minus 225 is 1800, so it is 49. Minus times minus is plus 49 plus 1800. Root of 49 plus 1800 over 4, so it is 7 plus minus, so actually r equals to 7 plus minus the root 49 plus 1800 is 1849 over 4. So in total we found out that the radius of the semicircle equals to r equals to 7 plus minus root of 1849 over 4. So the root of 1849 is 43. R equals to 7 plus minus 43 over 4. Okay, so that is the solution to our specific quadratic equation. So R can be equal to 43 plus 7 over 4. 43 plus 7 is 50. 50 over 4 is 12 12.5. So one possibility is that R equals to 12.5 units, and we have the other possibility that R equals to 43, 7 minus 43, 7 minus 43 over 4. 7 minus 43 is minus 36 over 4 is 9. So we found out that R equals to minus 9 units according to the second solution. R equals to minus 9, but R is the radius of the semicircle and it must be a positive number, so this possibility is incorrect, and we left only with the possibility that R equals to 12 over 12.5 units. We know that AB is the diameter of this semicircle. It equals to 2 times the radius, so the diameter that equals to AB is also equals to 2 times the radius of the circle. 2 times the radius of the circle is 2 times 12.5 units. That is actually 25 units. So we found out that the diameter of the semicircle that also equals to AB is equal to 25 units. Okay, we found out that the diameter of this semicircle equals to 25 units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the diameter of this semicircle. We know that CB equals to 15 units, CD equals to 15 units, and AD equals to 7 units, and we also know that AB is the diameter of this semicircle, and we want to find out the size of AB, the value of the diameter of this semicircle. So first of all, we made a construction. We connected together by a straight line points D and B, and actually the angle that was created, angle ADB, peripheral angle ADB, is a right angle, because we have rule number 1 that states that peripheral angle resting on the diameter of the circle or the semicircle equals to 90 degrees. Therefore, the peripheral angle ADB, this angle that rests on AB, that is the diameter of this semicircle, equals to 90 degrees according to rule number 1. Okay, again, rule number 1 states that peripheral angle resting on the diameter of a circle is equal to 90 degrees. So angle ADB rests on AB, that is the diameter of the semicircle. Therefore, according to rule number 1, angle ADB is a right angle, it equals to 90 degrees. Okay, then we defined the center of the circle as point O, and then we connected together points O and C by a straight line, and we also connected together points O and D by a straight line, and then we focused on the green triangle and on the orange triangle. On those two triangles, side TC of the green triangle is equal to side CB of the orange triangle. Both those two sides are equal to 15 units. So we have one side in the green triangle that is equal to the other side of the orange triangle, and we also know that OD equals to OB equals to R. Both those two sides are the radiuses of the semicircle, therefore they are equal to each other, and also OC is a common side, so OC equals to OC. It belongs it belongs to the orange triangle, and it also belongs to the green triangle. So we actually proved that three sides of the green triangle are equal to three sides of the orange triangle. Therefore, the green triangle is congruent to the orange triangle according to side rule. Side rule states that if all the sides of one triangle are equal to all the sides of the other triangle, then those triangles congruent to each other. Therefore, the green triangle is congruent to the orange triangle. And from the fact that the orange triangle is congruent to the green triangle, we can deduce that angle OCD equals to angle OCB. Those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. And we define those angles as alpha, so those angles that are equal to alpha also equal to each other. And then we focused on triangle DCB. On triangle DCB, we know that DC equals to CB. Both of those two sides are equal to 15 units. And we have rule number 2 that states that in front of equal sides in the triangle there are equal angles. So in front of those sides that are equal to each other in triangle DCB, we have those angles, and according to rule number 2, those angles that are located in front of equal sides are also equal to each other. So angle CBE is equal to angle CDE, and we define this angle as alpha, as theta. So both two angles are equal to each other, and they are also equal to theta. Then we focused on the green triangle, triangle CDE, and on the orange triangle, triangle CBE. On those two triangles, DC is equal to CB. Both those two sides are equal to 15 units. And also OE is a common side. OE is a common side. EC is a common side. EC equals to EC. It belongs to both triangles, to triangle ECB and to triangle ECD. So EC equals to EC, and those two angles are also equal to each other. Both of those two angles are equal to alpha. So we proved that two sides and the included angle in the green triangle are equal to two sides and the included angle on the orange triangle. Therefore, those two triangles are congruent to each other according to side rule. Again, the green triangle, triangle DEC, is congruent to the orange triangle BEC according to side angle side rule. Okay, we actually proved that two sides and the angle that included in the green triangle are equal to two sides and the angle included on the orange triangle. Therefore, the green triangle is congruent to the orange triangle. Okay? According to side angle side rule. Okay, so from the fact that those two triangles congruent to each other, we can deduce that this angle DEC is equal to this angle CEB. So we defined this angle as x, and this angle will be also equal to x because they are equal to each other. And then we focused on angle DEC. First of all, we know that DB is a straight line because we constructed DB. We actually connected points D and B by a straight line. So DB is a straight line. Therefore, along a straight line at a certain point on the upper side of a straight line at a certain point, the sum of the angles is equal to 180 degrees. So the sum of those two angles is equal to 180 degrees. So angle DEC is equal to 180 degrees from one side, but from the other side, according to our definition, angle DEC equals to x plus x, that is 2x. So we have the equality that states that angle DEB equals to 180 degrees from one side, but from the other side it equals to 2x. So from this equality we can deduce that 180 degrees equals to 2x, and if we divide this equality by 2, we will get that x equals to 90 degrees. Okay? So angle CED that equals to x is a right angle, and angle CEB that also equals to x is also a right angle. So those two angles are right angles. Then OC, chord OC, is the radius of this semicircle because of the fact that it starts from the center of the circle, that is to say from point O, and ends at point C, that is a point of the circle itself. Therefore OC is the radius of this semicircle, and from the fact that OC is the radius of this semicircle, we can deduce that OC is a straight line. OC is a straight line, so along a straight line, if we focus at point E, on the right side of point E, the sum of its angles must be equal to 180 degrees. Okay? So the sum of the angles in this side must be equal to 180 degrees. So this angle is 90 degrees. So this angle that is 90 degrees plus the size of angle BEO must be equal to 180 degrees. Okay, so we got this equality that states that 90 degrees plus the size of angle OEB must be equal to 180 degrees. From this equality you can subtract 90 degrees and we will get that angle OEB equals to 90 degrees. So actually this angle OEB, is a right angle. So around point E we have three right angles. This is a right angle, this is a right angle, and this is also a right angle. Okay, and we have rule number 3 that states that along the sum of the angles around any point is equal to 360 degrees. So the sum of the angles around point E must be equal to 360 degrees. Okay, we will focus on point E. We will create a statement that said that the sum of the angles around point E equals to 360 degrees according to rule number 3. And what is the sum of the angles around point E? It is actually the sum of the three right angles plus the fourth angle. So the sum of the angles around point E is actually the three right angles plus the fourth angle that we defined as Y. The fourth angle is Y. So angle Y plus the size of the other three angles must be equal to 360 degrees according to rule number 3. 3 times 90 is 270 degrees. So here we can subtract 270 degrees from this equality. We will get that angle Y equals to 90 degrees. So this angle also is a right angle. So we found out that all the four angles around point E are right angles. They are equal to 90 degrees. Then I drew triangle ADB and triangle OEB again, and we focus on those two triangles. First of all, we know that those two angles are equal to each other. They are both right angles, so angle ADB is equal to angle OEB. Both those two angles are equal to 90 degrees, therefore they are equal to each other. And angle B belongs to both to triangle OEB, and also angle B also belongs to triangle ADB. Therefore angle B equals to angle B. It is a common angle. And the fourth angle, angle DAB, equals also to angle EOB. Again, angle DAB, the third angle, equals to angle EOB. Those two angles are equal to each other according to third angle rule or third angle theorem. Third angle theorem states that if two angles in triangles are equal to each other, then the third pair of angles must be also equal in the two triangles according to the third angle theorem, because it is complementary to 180 degrees. Okay, so we actually proved that all the angles in the big triangle, triangle ADB, are equal to all the angles in the small triangle, triangle OEB. Therefore, we proved that the big triangle, triangle ADB is similar to the small triangle, triangle OEB. Okay. From this similarity, the following relationship exists between the sides of the two similar triangles. Those two triangles are similar to each other. Therefore, OB over AB equals to OE over AD. Again, OB over AB equals to OE over AD. But what is the value of OB? OB equals to R. What is the value of AB? AB is the diameter of the semicircle, so it equals to 2 times the radius. So OB equals to 2R. And we have also OE over AD. AD equals to 7 units. So in total we got that R over R equals to OE over 7. Here we multiplied this equality by 7 and we found out that OE equals to 7 over 2. OE equals to 7 over 2 units. And then we found the value of EC. EC equals to OC minus OE. Okay, EC equals to OC minus OE, but OC is the radius of this circle, of the semicircle, and we have already found out that OE equals to 7 over 2. Okay, so in total EC equals to R minus 7 over 2 and OE equals to 7 over 2. Then we focused on the two right triangles. Triangle OEB is a right triangle because of the fact that angle OEB is a right angle, and triangle CEB is also a right triangle because of the fact that angle CEB is a right angle. So we have here two right triangles, and we also know that side EB is common side. It belongs to both to the right triangle, triangle EOB. It also belongs to the right triangle, triangle CEB. So we implemented the Pythagorean theorem on those two triangles twice. We created the equality that states that EB square equals to EB square. And the first EB square is related to this right triangle. In this right triangle, EB square equals to OB square minus OE square. OB square minus OE square. Then the second EB square is related to this triangle. In this triangle, EB square equals to BC square minus EC square. EB square equals to BC square minus EC square. Then we know that OB is the radius of the circle, and we know that OE equals to 7 over 2 units, and we also know that BC is 15 units, and CE equals to R minus 7 over 2 units. So we solved this equality, and we got to a quadratic equation. So in this quadratic equation, the coefficients are A equals to 2, B equals to minus 7, C equals to minus 225, and the variable of this quadratic equation is R. That is the radius of the semicircle, and we have a general formula for a quadratic equation that is ax squared plus bx plus c equals to 0 when a, b, and c are the coefficients of the quadratic equation, and x is the variable that we want to find out, and we will find out the value of x according to a special formula that states that x equals to minus b plus minus root of b squared minus 4a squared over 2a. And we have already found out the values of a, b, and c, and x equals to r, the radius of the semicircle. So the only thing that is left to do is to substitute the values of a, b, c, and x by the values that we found out, and we found out that r equals to either 12.5 units, but it can also be equal to minus 9, but r cannot be equal to minus 9 because r is the radius of the semicircle, and it must be a positive number, so this possibility is cancelled, is not correct, and we left only with the possibility that the radius of the semicircle is 12.5 units, and the diameter of any semicircle or circle is 2 times the radius. And we know that AB is the diameter of this semicircle, so AB is equals to 2 times the radius. It equals to D, that is the diameter. So D equals to 2 times the radius. 2 times the radius is 2 times 12.5. That is actually 25 units. So we found out that the diameter of this semicircle, that is to say AB, is equal to 25 units. Okay? Thank you very much.